Hello guys, I am Rajdeep and you are watching Study SUCCOUR. Today we will discuss about various types of errors made in a measurement. Suppose absolute errors, personal errors, instrumental errors, etc. But before that we have to understand the actual meaning of errors in a measurement. So let's begin. We all know that the process of measurement is nothing but a process of comparison. To measure any physical quantity, we compare it with a standard unit of that quantity. Now, in order to understand what's a standard unit in details, you can view my previous video which I made entirely on standard unit. So, let's get back to errors. Let me repeat. The process of measurement is nothing but a process of comparison. To measure any physical quantity, we just compare it with the standard unit of that quantity. For example, in order to measure the distance between two blocks, we compare the distance with a measuring instrument. Measuring instrument like a measuring tape, a scale, etc. So, by this we get the distance between the two blocks. Now suppose the distance between the two blocks is 10 centimeters. So here we have assumed the distance between these two blocks as 10 centimeters. Now in order to verify it physically, we again need a measuring instrument like a measuring tape. So we take the measuring tape and compare the lengths marked on the tape with the distance, and thus we get the distance as 10 centimeters. Now these lengths which are marked on the tape are obviously marked according to the standard unit of the physical quantity length. Now please note that no measurement is perfect as the errors involved in a measurement cannot be eliminated completely. Hence, in spite of our best efforts, the measured value of a physical quantity is always somewhat different from its actual or the true value of the quantity. Now, let me explain the difference between measured value and a true value. The measured value, also known as the measurement value, is the value given by a measuring instrument, whereas the true value is the actual value or the real value of the property being measured. Suppose we have to measure the distance between two pencils. So it's obvious that we will measure this with the help of a tape or a scale. So let's assume that after measuring we got 10 centimeters, but the true length or the actual distance between them is 10.2 centimeters. So the measured value or the measurement value is 10 centimeter and the true value or the actual value of the distance is 10.2 centimeters. So we get 10.2 minus 10, that is 0.2 centimeter error in the measurement. Therefore, this difference in the true value and the measured value of a physical quantity is called the error in measurement, and for this case the physical quantity is length. So now we will talk about various types of errors made in a measurement. Errors are generally classified into two types: systematic errors and random errors. Systematic errors. Systematic errors are those type of errors whose causes are known. Such errors can therefore be minimized. For example, instrumental errors. This may be due to imperfection of design and manufacturing process of instrument. Often there may be zero error. The second one, personal errors. This may be due to the inexperience of the observer for lack of proper handling of the apparatus. Now the last example, errors due to external causes. This arises due to the change in temperature, pressure, humidity, etc. during the experiment. Relevant corrections can be made to minimize their effects. Now let's talk about the second type of errors, random errors. Random errors may arise due to large variety of factors. The causes of such errors are therefore not known precisely. Hence, it is not possible to eliminate random errors. If we repeat the same observation, this error can be minimized by repeating this observation a large number of times and then taking the arithmetic mean of all the observations. That mean value would then be very close to the true value. So, unlike systematic errors, the causes of random errors are not known precisely and cannot be eliminated completely. So now we will discuss about 5 types of random errors in measurement. The first one, calculation of errors. Here, the true value is considered as an arithmetic mean of the number of same measured values of a certain physical quantity large number of times. Let a physical quantity, say A, be measured n number of times. So, the measured values are, say, A1, A2, A3, A4 till An. So, each of these measured values are the observations. So, the arithmetic mean of these values is simply the sum of all the observations whole divided by the number of observations. Here, the sum of the observation, I mean the A1 plus A2 plus A3 till An whole divided by the number of times the physical quantity A is measured, that is n number of times. That means Am equal to A1 plus A2 plus A3 plus till An whole divided by n. Usually Am is taken as the true value of the physical quantity if the same is not known otherwise. I repeat, usually Am or the arithmetic mean of the values of A is taken as the true value of the physical quantity if the same is not known otherwise. That is, when the true value of the physical quantity is not known, then we take the mean value as the true value, because we all know that the mean value comes very close to the true value. Now we will move on to absolute error, second type of random error. Absolute error in the measurement of a physical quantity is defined as the magnitude of the difference between the true value and the measured value of the physical quantity. The absolute error may be positive or negative. By definition, absolute errors in the measured values of the physical quantity are, continuing with the assumptions of the previous error, del A1 equal to AM minus A1, del A2 equal to AM minus A2, and so on, completing with del AN equal to AM minus AN. So in order to explain, let me take the first equation, which is del A1 equal to AM minus A1. So now let's repeat the definition of absolute error. Absolute error in measurement of physical quantity is defined as the magnitude of the difference between true value and the measured value of the physical quantity. I repeat, difference between the true value and the measured value of the physical quantity. Now see the equation where del A1 is the absolute error in the measurement of the physical quantity A, which is equal to AM minus A1, where AM is the mean value or the arithmetic mean of the values of the physical quantity A, as discussed in the previous error, and A1 is an observation, for this case the first observation. I hope by now you understand why there is mean value in the place of true value. that is AM in the place of true value, because the mean value is very close to true value. So by continuing like this, you will get the absolute errors of all the observations. Proceeding to the third type, mean absolute error. It is the arithmetic mean of the magnitudes of absolute errors in all the measurements of the physical quantity, ignoring the positive negative signs of absolute errors. It is represented by del A with a bar on the top. So in order to ignore the positive negative signs of the absolute error, we have to use mod. So mean absolute error or the del A bar equal to mod del A1 plus mod del A2 plus till mod del AN whole divided by n, where you all know that del A1, del A2, del A3 till del AN all are the absolute errors, and n is the number of times the physical quantity A is measured, that is the number of observations, and we have used mod in del A1, del A2 till del AN for ignoring the positive or negative signs. Hence, the final result of the measurement may be written as A equal to AM plus minus del A bar. Why we have used plus minus? Because you all know that absolute error can have positive as well as negative values, and here AM, as discussed earlier, is the arithmetic mean, and del A bar is the mean of the absolute errors, which gives us the final result. This implies that any measurement of the physical quantity is likely to lie between AM plus del A bar and AM minus del A bar. Now the fourth one, relative error. The relative error, also known as proportional error or fractional error, is defined as the ratio of the absolute error to the true value. Therefore, relative error equals to del A bar by AM, where del A bar is the mean absolute error and AM is the true value, which is also the mean value. When the relative or the proportional error is expressed in percentage, we call it percentage error, which is del A bar by AM into 100%. Now the last type of random errors, that is the combination of errors. When a number of physical quantities are involved in the final calculation, then the errors involved in the measurement of all quantities will affect the final result. The error in the final result depends not only on the errors in the individual measurements but also on the nature of the mathematical operation. Suppose addition, subtraction, multiplication, division, powers, etc. We therefore need rules for calculating combined errors associated with different mathematical operations. So for that we have to see the errors in addition, subtraction, multiplication and division. I will only discuss the rules and the equations and not the derivations, as first year engineering students don't require the derivations. But if you need the derivations, then the comment section is always open for you. Or you can mail me via email. My email ID is given on StudySuccour's website, where you will get contact via email button on Contact Us webpage. Click on that button to send the mail. This will help me to know if you need those derivations. Then I will make another video on those. Link in description. So let's proceed to errors in addition. The maximum absolute error in the sum of two quantities is equal to the sum of the absolute errors in the individual quantities. Suppose x equals to a plus b. Then del x equals to plus minus of del a plus del b, where del a is the absolute error in the measurement of a, del b is the absolute error in the measurement of b, and del x is the absolute error in the calculation of x. Now errors in subtraction. the same formula as it was in the errors in addition. The only difference is the equation. Here the initial equation is x equals to a minus b. As you know, it's for the errors in subtraction. And the rule, maximum absolute error in subtraction of two quantities is equal to the sum of the absolute errors in the individual quantities. Now errors in multiplication and division. When two quantities are multiplied or divided, the maximum proportional error in the final result is the sum of the proportional errors in the quantities to be multiplied or to be divided. This means if we take x equals to a into b or x equals to a by b, then for finding the error we have to use the same equation for both cases. By error I mean proportional error, which is del x by x equals to plus minus in bracket del a by a plus del b by b, where del x by x is the proportional error in the final result and del a by a and del b by b are the proportional errors in the quantities to be multiplied or to be divided. And these quantities are a and b. So guys, that's all for today. Do like, share and subscribe my channel Study Succor. Come on, click the subscribe button. Anyway, it's free, who cares? And yes, I made this video mainly for diploma engineering students. Students of classes 11 and 12 also may find this video very helpful. And I'd like to thank Blue Music Records for sponsoring this video. Subscribe to their channel for more awesome updates on covers, remakes, mashups on Blue Music Records. Thank you.